Welcome to the DIY Honda Garage channel. DTC P0010 indicates a malfunction within the Variable Valve Timing Control (VTC) Oil Control Solenoid Valve A. The VTC system is critical for optimizing engine performance and efficiency by adjusting the timing of the intake valves, thus improving power output and fuel economy. The oil control solenoid directly controls the amount of oil supplied to the VTC system, affecting the valve position. If the commanded current to the solenoid does not match the actual current, meaning there's a significant discrepancy in performance, the Powertrain Control Module, PCM, identifies this as a fault and sets the Diagnostic Trouble Code, DTC P0010. This code may lead to performance issues or increased emissions if not addressed. Proper diagnosis will involve assessing both the solenoid's condition and the associated circuits, ensuring all components are functioning as intended. The Variable Valve Timing Control (VTC) Oil Control Solenoid Valve A is instrumental in the engine's timing functions. This component is often located on the engine near the timing chain or belt and plays a key role in adjusting the timing of the intake valves. The Powertrain Control Module, PCM, monitors the performance of this solenoid. If there is a divergence between the expected and actual operation, the PCM triggers the DTC P0010. The efficacy of the VTC system is paramount for peak engine efficiency, hence the need for thorough inspection. During diagnostics, components directly associated with VTC should be located and tested, including the VTC Oil Control Solenoid Valve A and the PCM itself, as they may significantly impact engine functionality. Several potential causes can lead to the activation of DTC P0010. One primary cause is a malfunctioning Variable Valve Timing Control Oil Control Solenoid Valve A. This could be due to internal wear, dirt, or electrical failures within the valve itself. Secondly, there may be faulty wiring or connectors compromising the integrity of the circuit. Broken wires, loose connectors, or corrosion can disrupt the electrical signals necessary for the solenoid to function. Furthermore, if both the solenoid and the external wiring check out, it may indicate a malfunction in the Powertrain Control Module, PCM, that requires further investigation. Each of these components must be inspected to identify the root cause of the issue. When DTC P0010 is present, several symptoms may become noticeable during vehicle operation. First, there might be evident engine performance issues, including reduced power output or sluggish acceleration, which can lead to an overall unsatisfactory driving experience. Additionally, poor fuel economy may arise due to improperly timed valve openings, causing the vehicle to consume more fuel than necessary. Drivers may also experience increased emissions as a malfunctioning VTC system fails to meet optimal exhaust conditions. These symptoms can significantly affect your vehicle's performance and efficiency, underscoring the necessity of prompt diagnosis and repair of the underlying problems associated with DTC P0010. The first step in troubleshooting DTC P0010 involves starting the engine and carefully monitoring its behavior. You should maintain the engine speed at a steady 3,000 revolutions per minute, RPM, without load. It's essential to ensure that the continuously variable transmission, CVT, is in park or neutral, or if you have a manual transmission, it should be in neutral. Holding the engine at this speed allows the vehicle's systems to stabilize, particularly the cooling system, as you'll want to wait until the radiator fan activates. Once the fan engages, you can transition to idling. This initial step is critical as it establishes a baseline condition for the subsequent diagnostics. ensuring all systems are ready to be assessed for proper functionality, specifically focusing on the variable valve timing control system. After successfully idling the engine and allowing the systems to stabilize, the next troubleshooting step involves utilizing the Honda Diagnostic System, HDS. Here, you will select the in-VTC function. This diagnostic tool allows thorough monitoring of the VTC oil control solenoid's performance against the expected parameters. It's crucial to examine the commanded current versus the actual current being reported by the system. If there is a significant discrepancy outside the specified range, this indicates that an abnormality exists within the VTC system. Establishing whether the command and actual currents are aligned will help narrow down whether the issue is with the solenoid itself or if wiring and connections need further investigation. For the third step in troubleshooting, the VTC oil control solenoid valve A must be disconnected. This allows you to safely inspect the internal circuit of the valve. You'll want to measure the resistance across the solenoid's terminals. The normal resistance should fall between 7.14 and 7.90 ohms at room temperature. If the measurement falls outside this range, it directly indicates that the VTC oil control solenoid valve A is malfunctioning. A problem detected here directs your focus toward either replacing the solenoid or investigating any obstructions affecting its performance. By determining the health of the solenoid at this stage, you can make informed decisions regarding necessary repairs or replacements to restore proper function. Proceeding to the fourth troubleshooting step, you must disconnect the PCM connector E, which contains 80 positions, and the VTC oil control solenoid valve A connector. This preparation enables you to test the wiring integrity of the associated circuits without interference. At this stage, you will inspect the circuits for the PG and VTC in lines. Both circuits should show less than 1 ohm of resistance when checked. If you find a higher resistance, it will suggest an open circuit or short, indicating a critical issue that needs addressing. Walk through all wiring, ensuring connections are tight and that there are no signs of fraying or exposure that could lead to circuit failure. Completing this step accurately provides insight into whether the issue lies within the wiring or if it has been isolated to the control solenoid. The fifth step in the troubleshooting protocol involves checking for any shorts to ground within the VTC inline. This is vital because a short could prevent the VTC solenoid from receiving the necessary electrical signals to operate correctly. You should test the line while it remains disconnected from the PCM. If the inspection shows that the line is not shorted to ground, it indicates that the circuit is intact and functional. Should you find a short, additional scrutiny is necessary to identify the source of the fault, leading to targeted repairs. This meticulous approach ensures that prior circuitry problems are entirely resolved before concluding the inspection process, ultimately ensuring the VTC system is ready for reinstatement into normal operation. In the final troubleshooting step, the PCM itself becomes the focal point for potential failure. After all other components and wiring have been assessed and found to be normal, any remaining concerns point to a malfunction in the PCM. To evaluate its health, specific functional tests must be executed and the responses compared to expected values. Establishing whether the PCM is operating correctly is essential, as a defective control module can lead to persistent DTCs and performance issues. Ensure that all diagnostic data, codes triggered, and operational parameters align with anticipated function to make an informed decision about possible repair or replacement of the PCM. Only after confirming the PCM's condition can you affirm that all elements of the troubleshooting process have been thoroughly addressed. Upon completing repairs associated with DTC P0010, it's crucial to conduct a final verification of the work performed. Begin by clearing any stored Diagnostic Trouble Codes, DTCs, in the PCM, as this will reset the monitoring system. Following this, a test drive should be undertaken to ascertain if the symptoms have been effectively resolved. During the drive, monitor for any abnormal characteristics or indicators of the previously identified issues. It's vital to ensure that no lights appear on the dashboard and that the engine operates smoothly throughout varying conditions. Successful completion of this step indicates that repairs were effective and the variable valve timing system is functioning normally, thereby mitigating any potential long-term effects on engine performance. Implementing preventive maintenance is essential to prolong the life and functionality of the variable valve timing system and the associated components. Regular engine oil changes are particularly crucial as they prevent sludge buildup within the VTC oil control solenoid. Clean oil ensures that the solenoid can adaptively respond to valve timing adjustments, optimizing performance. Furthermore, periodically inspecting the solenoid connections and wiring can preemptively identify wear or corrosion that may compromise system functionality. Lastly, consistent monitoring of overall engine performance can alert you to emerging issues before they escalate into more severe problems, allowing for timely interventions. Adhering to these preventive maintenance practices will significantly enhance the longevity of your vehicle's performance. In conclusion, DTC P0010 highlights the importance of maintaining functional variable valve timing operations for optimal vehicle performance. Understanding this code and its implications allows for timely diagnostics and appropriate interventions. Following a systematic approach to troubleshooting, beginning with starting the engine and proceeding through the various components, ensures that each aspect of the VTC system is thoroughly checked. Regular maintenance practices, such as keeping up with oil changes and monitoring engine performance, are vital to prevent DTC P0010 from reoccurring. By applying these principles, you can improve engine efficiency, reduce emissions, and prolong the life of your Honda Civic, benefiting both performance and the environment. Please like and subscribe to the channel. See you next time.